In this video, we are going to do a next level FindingK question. It would be really great to have previewed the PowerPoint up to this point just to get a sense of what the variation of the questions could be. But I would say that this is sort of a second level question. It's not a basic one, it's not the hardest one, but it'll give us a chance to kind of walk through these 4 steps that we do for each of the FindingK questions. So in this case here, we've got a decomposition reaction, and we were lucky enough that they had balanced the equation for us, because step 1 is always to make sure that whatever's given is balanced. So that is fantastic. What else is sort of given in the question? We are given a concentration for the carbon monoxide. We're given a concentration for the methanol. We need to find the concentration of the hydrogen. And also we're given a Kc value. So we want to make sure that all of our values are already in moles per liter. If you're given moles in 400 milliliters or moles in 2 liters, then you're going to have to convert them all into moles per liter. But again, we're really happy with this sort of concentration value already. So third step, write out the equilibrium law. We're going to confirm that there's no solids or liquids in our reactants or our products. So we're dealing with all gases. This is great. So for our equilibrium law, we're going to put our products over our reactants. So products over here, we've got the carbon monoxide and we've got the hydrogen, and then we're going to use that coefficient as the exponent. And then our reactants go on the bottom. And it'll be just sort of to the power of 1 because there's 1 is a coefficient. Last step is to substitute and solve. So, in questions where we have to find K, we've been given all the concentrations and we just churn it out. This one's a little bit different because as we substitute in, we'll see that our variable is going to be stuck in the numerator. So the x squared is the thing that we're trying to find. And so ultimately we want to get x alone on one side so that it's just 1x. First step, we cannot do anything to the numerator at this point because we have that denominator. So we're going to multiply both sides by 0.0406. If you like to cross multiply, that's fine, but really what we're doing, so we're timesing it by 0.0406, is we are creating that version of 1. And then we're going to rewrite. It's such a good idea to keep this kind of going up and down rather than left to right, because you'll sort of bounce up against your previous solutions. At this point in my calculations, I'm going to keep lots of decimals because any rounding will lead to greater errors down the road. So again, we want to get x by itself. The only way to unmultiply is by dividing. We always want to do the opposite operation. So again, we get to make that 1, and we'll do the same on the other side. I'm just ran out of some real estate here, so I'm just going to kind of continue everything up here with my value. And now I'm left with x squared, which is not the final answer. We still need to go one more, have one more math step or math move, because this is x times x. So in order to find 1x is, we're going to have to do the opposite of squaring, which is square root. So we'll take the square root of both sides. And we'll get something like 0.32, which is the concentration of the H2 gas. So moles per liter at equilibrium.